Let's have a look at exercise 5 over here. So what do we have? We have a company that employs one worker. The worker is intrinsically motivated, and we can see it in his utility function. So the utility depends on the wage. It depends on this gamma times E, and gamma is the effect of intrinsic motivation. So because he's willing to work, he's actually happy by working. That's why it's affecting the utility positive. But then there's still this cost of effort that anyway he's still getting tired from work, so that is decreasing his utility. Okay, now what's going to be in question 18, the optimal effort level? So because we have our utility function, depending on the effort, we have it over here that it depends on the effort. To find out the optimal effort level, we must maximize utility. We must differentiate the utility with respect to effort, because we can see that the utility depends on effort over here as a quadratic function with a negative coefficient. So in other words, we will have a parabola with a peak on the graph. So we'll differentiate the utility with respect to the effort and make that equals to 0. So let's see how that works out. When we differentiate utility with respect to effort, what do we get? Wage derivative with respect to effort is just 0. Gamma times E derivative with respect to effort is gamma. And then minus 1 over 2 times theta times E squared derivative with respect to effort. That's going to be 1 over 2 times theta times 2 times the effort equals to 0. Now we want to have only effort, so we take the term with effort to the other side. So we're going to take this one to the right over here, so that we will have gamma equals to 1 over, by the way, 2 and 2 cancel out, as we can see. 2 and 2 cancel out, so we're left with theta times the effort. But we only need the amount of effort, so let's divide both sides by theta, such that the optimal amount of effort is equal to gamma divided by theta. And what we can see here is that the effort is equal to gamma divided by theta, so the answer is true, and we are done.